We're playing hide and seek with Planet 9. This week on Planetary Radio. I'm Sarah Al-Ahmed of the Planetary Society, with more of the human adventure across our solar system and beyond. There may be a ninth planet in our solar system lurking out beyond Neptune. Our guests this week are Caltech's Mike Brown and Konstantin Batygin. They'll join us to talk about the latest evidence for Planet 9 and why they believe their hunt may soon be over. Then, Bruce Betts, our chief scientist, joins us for What's Up and a new Olympic-themed random space fact. I'm also really happy to share that the Planetary Society just passed over 100,000 subscribers on YouTube. Our new YouTube Silver Creator Award will soon have a place of honor in our recording studio. Thank you so much to everyone that watches our channel. You can also find Planetary Radio each week on YouTube and on YouTube Music. Every subscriber helps us reach even more space fans around the world. If you love Planetary Radio and want to stay informed about the latest space discoveries, make sure that you hit that subscribe button on your favorite podcasting platform. By subscribing, you'll never miss an episode filled with new and awe-inspiring ways to know the cosmos and our place within it. Most of the planets in our solar system have been known since ancient times. They shone so brightly in the night sky that you really couldn't miss them, and they moved in ways that the other stars didn't. Humans would later learn that this was because the planets orbited our sun, while the turning of the Earth caused the apparent motion of the stars on the sky. The word planet actually traces back to the Greek term asters planetae, which means wandering stars. In modern times, we know that there are at least 8 planets orbiting our sun, along with several dwarf planets, a bunch of moons, and many smaller bodies like asteroids and comets. But could there be another planet lurking in the dark and distant depths of the Kuiper Belt? The idea of another planet in our solar system beyond the orbit of Neptune isn't new. People have been suggesting it for ages, but it wasn't until 2003 that solid evidence really began to mount. The discovery of Sedna, which is a dwarf planet with a highly eccentric orbit, suggested that the gravitational influence of another celestial body might be at play. Today's guests, Dr. Mike Brown and Konstantin Batygin, began analyzing the orbits of other objects in the Kuiper Belt and noticed an odd pattern. Something was shaping the orbits of these bodies, particularly the ones categorized as extreme trans-Neptunian objects. Instead of having randomly oriented orbits, some of these bodies displayed a distinct clustering, with their orbits aligning as they approached their closest point to the sun, or perihelion. These clustered objects also had orbits that were unusually tilted compared to the plane on which the rest of the planets orbit, which is called the ecliptic. After a lot of work, in 2016, Mike Brown and Konstantin Batygin published a paper in the Astronomical Journal that proposed that these strange orbits of the Kuiper Belt objects could indicate another world orbiting our sun, which they called Planet 9. Their calculations suggest that this world has a mass between 5 and 10 times that of Earth, which could make it a possible sub-Neptune. Its predicted orbit is actually 20 times farther from our sun on average than Neptune would be. That means it would take somewhere between 10,000 and 20,000 years to orbit our star. Neptune, for comparison, orbits the sun about once every 165 years. So this Planet 9, if it exists, is way out there. And so the search began. For the last 8 years, Mike, Konstantin, and observers all over the Earth have been hunting for Planet 9. And the search is about to get even more interesting. With new telescopes coming online and even more data on the motions of trans-Neptunian objects, humanity may be just a few years away from one of the most significant discoveries in the modern era of planetary exploration. Konstantin Batygin and Mike Brown are both professors of planetary science in the Division of Geology and Planetary Science at Caltech. You may also recognize Mike as the author of the book How I Killed Pluto and Why It Had It Coming. Konstantin and Mike's new paper is called Generation of Low Inclination Neptune Crossing Trans-Neptunian Objects by Planet 9. It was published in the Astrophysical Journal Letters in April 2024. Welcome back to Planetary Radio, both of you.
It's great to be back.
Fun to be here. Thanks for having us.
It is so awesome to speak with you both in person after following your work for so many years. Because, I mean, come on, Planet 9, that was one of the biggest headlines of the last decade.
Yeah, sadly, it was almost a decade ago and we still haven't found it, but it's been pretty fun for the last decade.
The night is young.
Always.
Space is hard and it's huge. I mean, I once had someone ask me, why don't we know all of the asteroids out there that could hit Earth? Are scientists just not doing their job? And I was like, dude, look at the sky. There's so much to search, and finding a planet at that distance, that is a very complex problem. So I still have a lot of hope that you're going to be able to find this thing.
We definitely do too.
Yeah, we're not just riding on hope, but that's definitely a part of it.
And that's why I'm really happy to have you back, because the evidence for this thing continues to become more and more compelling, at least for me. There are still some alternatives that could suggest it, but you also address that in your newest paper. You get into a lot of those ideas for what could be the alternative. So we'll get to that in a moment. But first, what has it been like being at the center of this kind of excitement over something in space, not just for planetary scientists, but for the public more broadly?
Being able to tell people about what you're working on as a scientist and having them understand it and having them be excited about it is just an amazing privilege. You know, if we worked on some obscure area of cosmology or tiny particles that no one ever heard of, it's still important work, but it's a lot harder to get across the excitement. So it's just really fun to be able to talk to people about the exploration of the outer solar system and the fact that there are still big things to be found out there and that we're going to go find them.
Yeah, and I would just add that there's a real thrill to the fact that this is this theoretical thing has a relatively near-term resolution that's observational, right? Like Planet 9's either there or not there, right? And we're going to know not on a timescale of a century, but on a timescale of a decade from 2016. So any moment now. but it's kind of amazing, right, to be working on something where the kind of math and the computer simulations that we do really translate to direct observations on a short time scale.
On direct discovery, yeah. I mean, it's just super cool.
Although I feel like if I had been hunting for something that long, at this point, I'd be having stress nightmares. Like, I'd have a nightmare that I found Planet 9, and then it turned out to be a smudge on the lens or something.
No, the worst nightmare is somebody else finds it first, and then we read about it in the newspaper the next day.
Are there other teams that are competing to try to find this right now?
Absolutely. And one of the reasons why is because we've been as open as possible with all of our predictions on what the planet's like, where to find it, how to look for it. So I make the joke about somebody else finding it. Sure, we would like to find it, but we really want it to be found as quickly as possible. So that's why we really have made sure everybody knows where we think it should be in the sky.
And Mike, for some background for people who are just kind of getting into this story, you were part of the team that discovered Sedna in the early 2000s. How did that discovery lead you both on this crazy epic adventure to try to find Planet 9?
It's a funny question. It's Sedna. When we discovered it, we did not realize it was the first thing pointing to the existence of Planet 9. But that was a long time ago, so we weren't thinking about Planet 9. But we found this object. Sedna is on this incredibly elongated orbit that goes way to the outer part of the solar system, comes back in, not even that close to Neptune, goes back out again. And when we discovered it back in 2003, we thought, how can you get an orbit like that? And we knew something had to have gravitationally modified its orbit at some point in the past. And we thought the most reasonable assumption was maybe a star came by 4 billion years ago and kind of tugged it and pulled it along. And so we worked on that idea for about a decade, looking for more objects like it, until we finally realized that the story is actually much more interesting than some star a long time ago. It's a planet that keeps on doing it right now. So it's fun to be able to continue that story from a discovery 20 years ago.
And Konstantin, how did you kind of get put into this mix?
I came to Caltech for grad school in 2008, and I frankly did not know what the Kuiper Belt was or didn't care that it existed at the time. And I actually, so what's funny, I graduated from high school in 2004. I remember this dude in my class being like, yeah, bro, they found this like planet far away. And in retrospect, that must have been Sedna or Eris. And I was like, who cares, man? Like, we've got so much better things.
I know somebody who does.
Yeah. And so, yeah, I got involved really back in grad school working with Mike on trying to understand how the solar system evolved early in its lifetime, right after the disk of gas dissipate in like during that first few tens of millions of years to hundreds of millions of years. And, over time, when I came back to Caltech as a professor, we kind of linked back up and started thinking about, okay, where are we going with this? And there was a paper published right by our colleagues, Trujillo and Shepard, that pointed at kind of the tip of the iceberg, that there's something interesting going on. It was kind of obscure. There was a parameter called the argument of perihelion that was showing clustering at around 0 degrees. And this was like back in 2014, I guess, right? We're like, this is interesting, right? This looks legit and this is interesting. Like, let's figure out what's going on. And so that's kind of how we started back up on trying to understand, again, the present day architecture of the outer solar system. And for a couple of years, we made a takeouts reel, so to speak, where we would make all kinds of crazy models for how this clustering could occur, and it would be wrong, and we would move on to the next thing. And so it was a ton of fun.
I would say that we refused to consider the one that seemed the most obvious because it was dumb, which is that there was a planet out there. We're like, sure, there could be a planet out there, but we all know there's not another planet out there, so let's figure out what's really going on. We don't want to be stupid.
Right. There's a huge Bayesian prior against suggesting a planet in the outer solar system. Like, between the discovery of Neptune, right, in 1846, which was the only time that a planet had been properly and correctly discovered with math, perhaps, for now.
And maybe not even properly at that.
Yeah. Right. I mean, sure. But the fact is, like, a calculation was done and a planet really was there where Leverrier said it was. Between 1846 and, I don't know,
today,
2016 or today even, right, the number of people that have jumped up and down and said there's a planet out there is extraordinarily large.
I think it's like 35 or 36. I counted at one time. There's 35 or 36 kind of separate predictions.
Yes.
On using separate line of evidence or, something like that.
There was one guy about a century ago who I think alone predicted about 36 planets beyond Neptune. So the point is, like, there are a lot of crazy people out there who have predicted planets beyond Neptune. And there's the, like, Sherlock Holmes quote that I'm going to butcher, that, if you've ruled out every other possibility, however unlikely, the remaining one is the correct one or something. So that's really how we arrived at this. It wasn't, looking at a plot and saying, oh, here we go, there's a planet, right? It was years of not being able to figure it out with any other mechanism. And we've really, I think, done our due diligence on, even back then, on trying to come up with something more exotic than a planet. That's how this story started for us.
And the funny thing about a planet is having a planet in the outer part of the solar system is actually a pretty mundane explanation. In the grand scheme of things, we see other stars in the galaxy with planets not dissimilar to what we think Planet 9 is like. There's no really particular reason for us to think it's extraordinary that there would be another planet, except for that psychological feeling that for all these years we've been telling ourselves and telling everybody else there are no other planets to be found out there, and we really bought into it.
It kind of feels like that feeling where people say that, there's all these things in the deep ocean that you haven't discovered. Knowing it's right there and that we're so unaware of it is kind of terrifying. It points to the breadth of stuff that could be impacting us that are just so far beyond our experience, right? But also, who's excited that there's some weird new fish down there? Of course there's a new fish down there. Like, I would not be surprised if Planet 9 was lurking out there, but what a headline. Everyone's brains would be on fire.
It'll be fun.
I'm excited about the fish.
Me too.
I'm excited about Planet 9. I'm excited about both.
And shortly after the story came out in 2016, I was working at Griffith Observatory, which I know you're both very familiar with because you both came there during the time that I was a show producer and presented there. And at the time, the question I kept getting from people over and over again is, well, Pluto's not a planet. How do they know this thing is a planet? And I think this is a perfect question to put to you, Mike, because it gets to the heart of that reclassification of Pluto as a dwarf planet and what the IAU definition of a planet is. And just in case anyone is listening to this and wants to know why that is, it has to do with this population of worlds out there that are being potentially influenced by Planet 9 and how we even think it's there in the first place. So would you be willing to explain a little bit about that?
If you look at the solar system now, if you look at it with fresh eyes, instead of the progression of discoveries that were made along the way, you realize very quickly that the solar system divides itself into, forget about Planet 9 for a minute, it just divides itself into 4 giant planets, 4 terrestrial planets, asteroids between the two, and these icy Kuiper Belt objects, kind of like icy asteroids outside the giant planets. And the planets basically ignore everything except each other. And the things that are not planets are flitting amongst the planets. They're getting ejected by the planets. Their orbits are being perturbed by the planets. Planets don't care. They just go around the sun, only talking to each other, ignoring all these other small things. And when you say you have found a new planet, what you're actually saying is you found another of these major bodies of the solar system that really is only being influenced by other of these major bodies. And this is what Planet 9 is. Planet 9, we think, is somewhere in the vicinity of 7 times the mass of the Earth, which would put it at something like 2 times the radius of the Earth. This is not like slightly bigger or slightly smaller than Pluto, and let's argue about it. This is the 5th largest planet in our solar system, bigger than all the terrestrial planets put together. No one would argue that this thing is not a planet. It's affecting a huge swath of the area of the volume of the solar system. I think I would declare it to be the most planety planet out there.
Yeah, and to riff on that, if you really track where the whole Pluto is a planet thing came from historically, right? It came from the fact that at the time it was discovered, right, Parzival Lowell had tried to use math to predict a trans-Neptunian planet, which weirdly he said was 7 Earth masses and was kind of on a Pluto-like orbit.
To be fair, he said many different things. He also said it was bigger than Jupiter at some point.
Yeah, he also didn't do any of his own calculations, which is
credit.
Yeah. So the interesting, like when Clyde Tombaugh discovered Pluto, because they were looking for this thing they called Planet X at the time, he found it and they said, well, that must be it. But because you can't measure the mass of something by looking at it, you can only make an educated guess, and the educated guess at the time was 7 Earth masses.
The New York Times headline on the day of discovery said possibly larger than Jupiter.
But the hilarious, right, they couldn't resolve the disk, and Clyde Tombaugh was like, well, given that we can't resolve the disk and it looks like a point source, it's probably less than 7 Earth masses, so it's probably 1. And that's how that number came about. It was like 1. Then Kuiper was later like, well, maybe it's like half, right? So it was until 1978, before Pluto's mass was measured, this notion that it was a Earth mass object was kind of floating around the literature. And so that's really where the Pluto's a planet thing historically came from, but it's founded on erroneous calculations.
Yeah, so this is why I always say, like, it's not really that Pluto was reclassified; it's that it was incorrectly classified the first time around, and now we've gotten it right. The other fun historic fact to think about is Pluto was found in 1930 because it's one of the intrinsically brightest Kuiper Belt objects, and it happened to be relatively close to the sun at the time. There are a couple of others that could have been found by Clyde Tombaugh had they been in a point in their orbit where they were closer to the sun, like Eris, Makemake, Haumea. Clyde Tombaugh could have found them all if they were closer to the sun at the time, and none of them were. But if he had found first Pluto and then thought, weird, I wonder what this is, and then found Eris and then found Makemake, everybody in astronomy would have said, oh, it's just like the asteroid belt. There must be a million of them instead of being a planet. Instead, it was found in 1930. The next large one wasn't found for more than 70 years. And so it was a long time before people realized that population is extensive as it was.
And this Planet 9 that we're now trying to look for is going to be way more distant than Pluto ever was. So trying to find something like that is going to be very difficult. And this is even one more illustration of how complex this search is. The sky is very vast. These objects are very distant, very far from the sun, very small in some cases. It is a wonder that we know so much about the outer solar system at this point, given how complex this issue is. And that's what's so beautiful about the fact that we know so much about Planet 9, despite not having found it yet. It is the discovery of all these other trans-Neptunian objects and the analysis of their orbits that's allowed us to try to narrow this down. But even at the time that, you first published that first paper and everyone was considering this, you were looking at a particular kind of extreme population of trans-Neptunian objects with very strange orbits. And I remember at the time people commenting, well, maybe this is like an observation bias thing. Maybe it's just the ones that we're looking at, where we're looking at. But in your more recent paper, you've expanded that to a broader population, a different kind of population of trans-Neptunian objects. How are those different, and what are they telling us about the search for Planet 9?
The first kind of hint of the existence of Planet 9 were the kind of the most exotic Kuiper Belt objects, right? These are the things that have the largest orbits that, like Sedna that Mike talked about before, right, have perihelia, closest approach to the sun, pulled out so that they don't strongly interact with Neptune. So they're kind of the most pristine sample size of the outer solar system. They all point into the same direction. Now, of course, all astronomical observations are subject to biases. So this came up as this question of like, well, do we really know it's intrinsic? And you can do statistical calculations and put numbers on it. But the paper that came out, a couple of months ago, right, we took a different approach of saying, let's not look at the most exotic, let's look at the most mundane part of the outer solar system, which is the population of kind of long period objects that live in the same plane as Neptune. They cross the orbit of Neptune, so they're kind of easier to discover. They're all over the place. Let's just look at that population, ask, is there something there? And the mere prevalence, the mere existence of these objects is actually already a hint of something that's affecting the outer solar system from beyond Neptune. Why? Because Neptune's gravity tends to scatter them out, right? If you just leave the population that we observe alone in the solar system for 10, 100 million years, they're all gone. This means that something from beyond Neptune is injecting them back, right? And that we're seeing this stream of stuff. And that there are only two possibilities. Either it's the galaxy, meaning the tide that comes from the galaxy and the passing stars, or it's Planet 9. So we simulated both of those scenarios with the best large-scale simulations that have been done to date, right? The most detailed ones, carrying the solar system's evolution from its infancy to its current state. And what these calculations demonstrated, and you can really see it by eye in the outcome of the calculations, that the Planet 9 free simulation is ruled out, right? And statistically, it's ruled out at 5 sigma, okay, which is pretty high degree of statistical significance. Conversely, the simulation where we put in Planet 9 that is a generic one that we've been using now for 7 years or something like that, the simulation is indistinguishable from the observations, right? So this is a completely different line of evidence for the existence of Planet 9, but the fact that it is perfectly explained by the same Planet 9 that explains the clustering, by the same Planet 9 that explains the high inclination populations, et cetera, really cumulatively, I would say, suggests that it's the simplest explanation, right? To maybe riff off of something Mike said a little bit earlier, if you look in the solar system, like if you look in the asteroid belt, there's all kinds of structure. Why is it there? It's there because Jupiter is there, right? If you didn't know Jupiter is there, but you saw the asteroid belt and you knew something about orbital dynamics, you could say, wow, there's probably a planet out there. And you could probably calculate exactly where Jupiter is. And the same thing with the kind of conventional Kuiper belt. Things like Pluto, right? They are corralled into the 3-2 resonance with Neptune. There's all kinds of structure. There's not a population of minor bodies in the solar system that does not exhibit structure, okay, which is caused by a planet. So in a way, even though it sounds kind of, psychologically weird, right? All of this structure that we see is shaped by the planets, and we're just starting to unveil the most distant aspects of it.
What's cool about that is that if we understand that, if we really study that within our own solar system, that could allow us to infer things about distant star systems as well. And analyzing this population of Kuiper Belt objects has kind of allowed you to, narrow our parameters on what Planet 9 might be like. Have we found any exoplanets at similar predicted distances and similar predicted sizes in other star systems?
Yeah, I forget the license plate, but there's one that's just like Planet 9. It's HD 11 something. Yeah, but
I don't remember either.
Yeah, I mean it's more massive and it orbits a binary star, but the orbital period and the eccentricity look just like what you would infer for Planet 9, and that's because the process that puts planets at hundreds of AU away from the sun is a generic process, right? It's not something that is weird about the solar system, right? All stars tend to form in associations. They form with other stars. And gravitational dynamics is chaotic. So when planet formation is happening, planets are getting ejected and they get affected by these clusters of stars that can park a fraction of them at hundreds of AUs away. That's what's happening. And in fact, in the solar system, if you don't have any evidence for Planet 9, right? This is not work that we've been doing, but some of our colleagues have been doing these calculations of just forming Uranus and Neptune. And just from the fact that Uranus and Neptune have to form, right? And Uranus has to get tilted by a giant impact. From that alone, you can calculate the probability that a 5-ish Earth mass protoplanet would get stuck at hundreds of AU, and it's 40%. So that's the baseline kind of expectation value, if you will, that a planet of many Earth masses, right, exists at hundreds of AU.
It really is a somewhat mundane explanation, even though it's a very exciting mundane explanation.
We'll be right back with the rest of my interview with Mike Brown and Konstantin Batygin after this short break.
The Planetary Society is strongly committed to defending our planet from an asteroid or comet impact. Thanks to the support from our members, we've become a respected independent expert on the asteroid threat.
So when you support us, you support planetary defense. We help observers find, track, and characterize near-Earth asteroids. We support the development of asteroid mitigation technology. And we collaborate with the space community and decision makers to develop international response strategies.
It's a lot to do, and your support is critical to power all this work.
That's why we're asking for your help as a planetary defender. When you make a gift today, your contribution will be matched up to $25,000 thanks to a generous member who also cares about protecting our planet.
Together, we're advancing the global endeavor to protect the Earth from asteroid impact. Imagine the ability to prevent a large-scale natural disaster. We can, if we try. Visit planetary.org/defendearth to make your gift today. Thank you.
What's cool, too, is that mass range puts it in this kind of sub-Neptune range of worlds, which we've found in other star systems are the most common type of exoplanet in our galaxy, at least as far as we know. And finding one in our own solar system could be a really cool thing, not just for our understanding of planetary formation, but even just being able to analyze something like that with, say, JWST could help us learn a lot about these other worlds.
It'll be interesting because it is, similar mass range to some of these other worlds, and yet it might be extremely different. These other worlds we know about in this mass range are on orbits inside the orbit of the Earth, inside the orbit of Mercury, super hot. This thing is way out there, super cold, formed on the outer part of the disk. Maybe there'll be similarities, maybe there'll be differences. It'll be just, discovering these things is exciting, but you're absolutely right. It's the studying them after we discover it, where we're going to really learn the good scientific insights.
And I know at least from what I've read online, it seems that both of you think it's probably way more likely this object, if it does exist, formed with the rest of the solar system. But some people have suggested if it exists, maybe it's a captured rogue planet or something like that. If and when we do find it, what would we need to know about it in order to discern which of these two things is true?
Yeah, it's hard to discern definitively. I mean, the rogue planet makes for a better Hollywood scenario, but the problem with the rogue planet explanation is that we know how that process works, right? A different star has to come in and drop it off, right? And the issue is that if your stellar environment is dense enough for that to happen, then the next star that passes by strips it away. So the possibility of retaining a rogue planet, even if it gets parked, the probability is low. That's really the argument. I don't think that we'll learn anything additional by looking at the planet on whether it's rogue or formed in the solar system, unless we are able to get down to, really doing kind of cosmochemistry on it.
I'm more optimistic. I actually think that we will learn things about the composition, about the amount of different elements in it, and there are differences between what we see around our sun and around other stars, and we may be able to tell. And while I 100% agree with Konstantin about what I think is the most probable, I will also say that our ability to predict things about planets we haven't ever seen is pretty close to zero. And so anything that we're saying that turns out to be different from what we're saying will not surprise me in the least bit. We are notoriously bad about planetary predictions and what the planets are going to be like. So it'll be fun to see what it really is.
Well, we're only just beginning to have the technology to analyze other worlds' atmospheres and stuff like that. Like, I know that it may seem from the public perspective like we know a lot. I feel like we're just taking our first steps into the realm of understanding anything about planets at all.
Yeah.
Yeah, absolutely.
So we think this is the most likely explanation, that there's another world out there. But as I said earlier in your paper, you do go through some of the other ideas of things that could have happened to cause these strange orbits. What are some of the things that you considered, and why do you think they're far less likely?
There's a whole range of things that have been proposed as alternatives to Planet 9, if you will. One of the kind of explanations that has gotten some traction in the literature is that the Kuiper belt itself, right? That there's a ring of material that's about 20 Earth masses in total. So it's not a planet; it's the self kind of gravitational shepherding of the outer solar system, and that is actually one of the explanations we looked into back in 2014 and then kind of abandoned. But earlier, I think last year, we looked into this in much more quantitative detail, and it just doesn't work. The solar system that you would get would look different, and also Neptune scatters it all away. If you really do the modeling correctly, it doesn't work. So another one is that we don't know the law of gravity correctly, right? MOND, right? MOND was an explanation that made headlines last year. And again, when you go through the modeling of that carefully, and this is not something we've done, but this is something that had been done by our colleagues in the literature, it doesn't work. Like, you break other parts of the solar system, like the Oort spike would go away, right? And so each one of these explanations kind of falls apart when you go in deep and you go beyond the superficial. Another one is the one you had mentioned already, right? Could this all be, some deep state level conspiracy of various telescopes that all looked in the same place and stuff like that? And I think, Mike had done a tremendous amount of work on this in the last 5 years, specifically for the kind of exotic population. But for the new paper, right, I think you can take all that into account very carefully. And again, the answer is, it's really, really unlikely. So I think it's really important to not ignore the alternative explanations, right? To give them the full attention that they deserve and to go through each one and really model them carefully. If we're wrong, that's okay. But so far, there hasn't been a distinct model that predicts all of the features of the solar system correctly. And that's a very unusual thing. Like, Mike and I have been surprised by this in the past, right? Usually when there's an interesting astronomical observation, there's simultaneously 25 different theoretical models that all predict kind of the same thing. And then it's like, a century later, you decide that, well, one is indeed more likely than another. In this case, there isn't really a compelling, distinct theoretical explanation.
Which it leads to one of the questions that people often ask, which is, when are you going to give up? If you don't find it, we haven't found it for 8 years. how many more years are you going to keep looking before you give up? And the answer really is that until there is a better theoretical explanation for these myriad phenomena that we see, Planet 9 remains the best explanation, even if we can't yet find it because it's a little too faint and too far away. If somebody comes up with an explanation, or it would have to be probably 5 or 6 separate explanations for all these other things, that works well, then I think everybody would consider that maybe it's that there is not a planet out there. But so far, there are basically 0 other explanations. So I'm sticking with this one.
Yeah, and you guys have gone through the Pan-STARRS survey data. You've used the Japan's Subaru telescope. There's so much data you've gone through, but as we pointed out earlier, our technology is limited. And thankfully, we are just a couple years off from having this new Vera Rubin telescope. And I think this is really going to change this hunt up. How do you think this is going to help you hunt for this thing? And I mean, it's hard to predict, but if it is out there, how long do you think it's going to take?
I can predict this right now. So let's say that the Vera Rubin Observatory comes online in about a year. Who knows exactly when it's going to really start, but let's say a year. In a year from now, it starts to scan the sky, and it kind of covers the whole sky every, let's say, 3 nights, the whole sky that it can see from South America. And over the course of a year, it has done the entire southern hemisphere, including most of the places we think Planet 9 is going to be. It will have seen Planet 9 many, many, many times if Planet 9 is bright enough, and we'll find it. We'll find it within the first year of Vera Rubin Observatory if it's bright enough for Vera Rubin Observatory. But even if it's not bright enough for Vera Rubin Observatory, what we will continue to find are more and more of these objects in the outer solar system that are being affected by Planet 9. And with the massive data set from Vera Rubin Observatory, there will be no questions anymore about, is it true? Is there maybe observational bias? The answer will be no. Vera Rubin will be very easy to calculate what that is. There will still be this big cluster. These objects that Konstantin was talking about are still being pushed in past Neptune. It will really cement the phenomenology, even if it doesn't find the object. And I'm hopeful that it'll actually just straight up find the object.
Even if Vera Rubin actually fully fails and doesn't discover any additional thing, like 0 additional discoveries, that will still prove everything that Mike just said, because if you just recover the cluster that we see with a uniform survey, like, it's done, right?
So I just want to make sure that that's clear. It's not that if it fails, because if it fails, it means it's not working. If it works and spends all year looking for new objects, and the only objects that it finds are the old ones that are clustered, that means the old ones are clustered.
What you said, that's an epic fail. What I said,
no, that is an incredible success.
Yeah.
That's what's so great about this. I mean, not only does the countdown start the moment this thing goes online, but even if we don't find it, the things that it could tell us are amazing. Either there's a planet out there or there's something really, really wacky going on.
Yeah, call us August 1st, 2026, and we'll tell you the answer.
I'll put it on my calendar because honestly, I know we never want to make definitive statements before we've actually found a thing. But the evidence for me, even in 2016, was very, very high that this existed. And at this point, the math kind of speaks for itself. And I think people should get really excited about this. And they are, clearly.
And to be fair, scientists are a skeptical lot. And so there are many in the scientific community who will remain skeptical until the day it's seen through a telescope. And a lot of that is because of what we talked about earlier, that so many people have said, there's a planet, and have always been wrong. So the instinct is for anybody, if anybody says there's a planet, is to say, really? This is what Konstantin and I would have said if somebody else had said there's a planet. We've been like, really? But if you look at the evidence, I think, we would agree. If you look at the actual evidence, it's pretty hard to come up with a different explanation.
How did you determine when you had enough evidence to go public with it? Because I bet that was tense.
We determined it when we had a prediction in our calculations, when it was like, all right, we have a clear, dynamical pattern of how, if this planet is there and it explains this clustering that we see, how it would create a population of highly inclined, highly tilted orbits in the solar system. And Mike had remembered that a bunch of these orbits had been already discovered by the WISE mission. Nobody kind of made a big deal out of them. So I remember that we were at Mike in your office, right? And we're like, okay, so I brought the theoretical prediction, and we're like, let's see where the real objects fall, because if they fall on this clear kind of pattern, right, we're gonna just freak out. And it was like, there are not that many actual eureka moments in science, right? Most of it is a grind, but this was one moment where seeing those dots appear on top of the simulations was a really compelling moment where, we kind of sat in a brief silence. We're like, and that's kind of a moment when I think Planet Nine kind of crystallized from us joking around about how we're just one of these other dumb people that just like, lose it at some point, and they start talking about planets out beyond Neptune to like, oh man, this might actually be real.
So for me, I always think of it as when we first did those simulations and matched it with the cluster, and we're like, okay, that's a good explanation. But explanations of data that you already have are pretty easy, particularly, theoretical astrophysicists can do that kind of stuff all day long. That doesn't have to have any attachment to reality. But a prediction is the time-honored way to really convince yourself that you know what's going on. And so we made this prediction and checked on the data. And it really was the moment when it went from like this cute project that was kind of fun to see if we could explain why these things were out there to, there's a giant planet out there. We need to go find it.
Yeah.
It's also a pretty opportune time for this search to be happening because we finally have JWST online, right? If you happen to find this world during the time that the telescope is still operational, maybe you can claw some telescope time out of that and actually point it at this thing. Because, finding it would be one thing, but being able to identify its moons or if it has rings, anything like that would just be absolutely mind-blowing.
Yeah, the big hope is that we find it while HST is still up in orbit, because HST still is the premier for things like moons and rings. But JWST will be fantastic for studying its atmosphere, assuming it's like a giant planet kind of thing, looking at its atmosphere, looking at its composition, looking at the residual heat that's coming out of it. We sort of have plans for all sorts of telescopes across the world, what we'd like to do the day it's discovered.
I'm glad to hear that you're already making those plans because, telescope time is notoriously difficult to get. And the more views we can get on this thing, if and when you find it, I think the entire astronomical community and every telescope we've ever built is going to be pointing at this thing.
I think you're right.
So what are you going to do when you find it? If you find it, how are you going to celebrate?
How are we going to celebrate? Diner at 3 a.m.
That's what we do. Diner at 3 a.m. Then we drink these tiny little bottles of rum with hats on top of them.
I was just thinking, if we find another world, we're going to have to redo our whole Planetary Society headquarters. Like, we're going to need to put it in our scale model. We'll probably have to repaint all the walls. And I bet Caltech would want to throw a big party to celebrate as well.
We're always partying anyway, so it will just be another Tuesday.
Yeah, it's true.
I know no single person can name an object like this, and I know you've probably gotten a bunch of suggestions from people over the years, but if you could name this object at some point, do you have any favorite names in mind?
I will tell you a very important thing, which is that astronomers, I believe, are amongst the most superstitious of scientists out there. And, partially it's the ancient connection to the sky. Part of it is that our scientific work is so intimately connected to the weather and things like that. So every astronomer I know has their own sort of voodoo magic to make the clouds go away. But one of my very strongly held superstitions is that if you name an object before you find it, you will not find it. And so we have really quite carefully avoided speculating anything about names or anything else. So as soon as we find it, we're open for business. Send us your suggestions. Until then, I'm going to stick my fingers in my ears, and if you say anything, and then I don't hear you, I can't hear you.
So while Mike has his fingers in his ears, the answer is David Bowie. Okay, and this is because it's already in the literature, right? There's some paper from 2016 or so with Nick Cohen because there was some Change.org petition that was addressed to us and the IAU. And this made it into the literature. There is a paper that refers to Planet Nine as David Bowie. And the reason for this is less stochastic than you'd think.
Or more.
Like David Bowie's final album, right, was called Black Star or Dark Star or something like that.
It was Black Star.
Black Star, yeah. It came out like a week before the paper. So I think it came out like the same day that the paper was accepted or something like that. So the analogy there is deep. And think about it. We could have Jupiter, Saturn, Uranus, Neptune, and David Bowie.
Thank you so much, Mike and Konstantin. And seriously, when this goes down, if I can, I'll come by your office and bring you a little model of your planet. That'd be super fun.
Awesome. Thanks.
Sweet. Thank you so much.
Thank you.
Now let's check in with Dr. Bruce Betts, our chief scientist for What's Up. Hey, Bruce.
Hi there, Sarah. It's good to talk with you today.
Did you hear the good news about our YouTube subscribers?
They're all happy?
Yeah, because we just hit 100,000 subscribers on our channel.
Party on, dude.
Party on. Now, I'm looking forward to getting the plaque for our silver award and hopefully putting it in a place of honor in our recording studio.
We got silver?
We did.
Cool. Do we have a chance to get gold at the next YouTube Olympics?
If our YouTube subscribers can help us to our goal. Have you been having a good time watching the Olympics over the last few weeks?
Oh, yeah. Totally.
Man, like the memes coming out of the Olympics this year are golden. So this week I got to talk with Konstantin Batygin and Mike Brown about Planet Nine, which is really cool. This is a story I think a lot of the people in the scientific community have been following for almost a decade now. And I'm really rooting for them. I hope they find this planet out there. What are your feelings on it?
Keep looking.
Right.
No, it's interesting. And as you probably discussed, has the analogy with the finding of Neptune using perturbations, but they're doing something much more crazed, but then we have much more powerful things to do that with these days to actually calculate the perturbations of this way out possible Planet Nine.
And that's what's interesting about it, because, I said this earlier in the show, but most of the planets, it's hard to even say they were discovered. They were just in the sky. You could see them, right?
Yeah.
But it did get a little wackier as we went out past Saturn. And even Saturn, we didn't fully understand until we got to look at it through a telescope, right?
Well, it was a planet.
Yeah. We didn't know how it had rings, though.
Well, no, but we didn't know the others had rings until much, 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 much later.
That's true.
Much to the chagrin of editors I've had on some of my children's books, there is not a date or a person you can ascribe to the discovery of all the planets that can be seen easily in the sky, which goes out to Saturn. People have been seeing them. You can see them yourself when you go out there. If they're up in the sky, they're easy to see. Uranus is actually visible with the naked eye if you're in a really dark site and have good eyesight, but no one came up with that one until they invented the telescope.
Who was it that found that one? Because, as you said, we could have seen it with our eyes, but we didn't have to use math to calculate where that guy was.
Billy Bob Herschel. Okay, William Herschel, with assistance from, I can't remember if Caroline Herschel, his wife, did a lot of stuff mostly on comets. And then he had a son who did stuff. There was a whole family of astronomy, but he found it. And actually, my impression is it wasn't just watching it move. He actually resolved it enough to see that it had a disk, which you can do with a modern small telescope. And so became curious. On the other hand, for a while, he was just calling it a comet. And then they came up with the orbit, and it became it must be a planet. In our Planetary Society's Random Space Fact videos, there's one I very much like where we did a planet named George because he wanted to name it after King George III, his current benefactor at the time. But not surprisingly, other countries were not into it, and they got into a whole little wrangling battle. And somehow, which I could go into because it's its own weird, fascinating story, we ended up with the Uranus thing, which is weird. Sorry, I'm rambling, but it's just such an odd story since it's a Latinized version of a Greek god's name rather than the equivalent Roman god like all the rest are. Anyway, I love that part. I also love a little thing I like to call Random Space Fact. All right. It's Olympics time, and I apologized last week for not having an Olympic thing. So now I've got several lined up for a while. So today we're going to look at swimming, specifically in the pool. And let's just say that the Earth distance from the sun was the equivalent of the shortest swimming race, 50 meters, one lap in a long course pool like they use, one lap, Earth to the sun. How far would it be from the sun to Neptune? It would be the length of the longest competed swimming race in the pool, the 1,500 meters, which is 30 laps. It's about 30 times farther. So, there you go. Shortest race, the longest race, that's sun to Earth, sun to Neptune.
Man.
There you go.
Don't let your arms get tired on your way to Neptune. Wow.
Yeah, there's so much flapping. Especially due to the lack of atmosphere to push against.
Nah, that's a really long way. And then you think about that in contrast to how far they think Planet 9 might be. They're saying it's maybe 20 times on average the distance that Neptune has to the sun. So that's a lot of swimming.
All right. You good? We good?
We good.
All right, everybody, go out there, look up in the night sky, and think about where you predict Planet 9 to be. Go ahead, point up in the sky right now, and remember that in case they find it. Thank you, and good night.
We've reached the end of this week's episode of Planetary Radio, but we'll be back next week with the Canadian students behind Team Insecta. Could crickets be a good source of protein and a Kickstarter for space agriculture? Only science will tell. If you love our show, you can get Planetary Radio t-shirts at planetary.org/shop, along with lots of other cool spacey merchandise. You can help others discover the passion, beauty, and joy of space science and exploration by leaving a review or a rating on platforms like Apple Podcasts and Spotify. Your feedback not only brightens our day, but helps other curious minds find their place in space through Planetary Radio. You can also send us your space thoughts, questions, and poetry at our email at planetaryradio@planetary.org. Or if you're a Planetary Society member, leave a comment in the Planetary Radio space in our member community app. Planetary Radio is produced by the Planetary Society in Pasadena, California, and is made possible by our members who totally want another planet to add to their scale models. You can join us and help support planet hunters everywhere at planetary.org/join. Mark Hilverda and Ray Paletta are our associate producers. Andrew Lucas is our audio editor. Josh Doyle composed our theme, which is arranged and performed by Peter Schlosser. And until next week, Ad Astra.